Chapter 2 about oxidation reduction potential. General ideas. مثل ما بنعرف الجالفانيك سيل قلنا it's a device used to convert chemical energy into electrical energy. لازم نعرف انه electrons بشكل عام flow from anode to cathode، فدائما الالكترونز بيطلعوا من الانود side to the cathode side، while current flows from cathode to anode. الكرنت بالعكس. At anode zinc strip is oxidized. مثل عم نلاحظ هون على منطقة الانود بنلاحظ انه zinc strip is oxidized, so zinc strip becomes thinner. The concentration of metallic ions in the beaker at anode increases. Zn2 plus increases. لاحظوا كمية Zn2 plus هون عم بتزيد لأنه عم تعمل oxidation. So at anode مثل ما ملاحظين strip becomes thinner. At cathode CO2 plus solution is reduced. عم نلاحظ إن CO2 plus بتساوي reduction. So CO strip becomes thicker. فنلاحظ إنه هون حتتخن CO strip لأنه becomes thicker. The concentration of metallic ions in the beaker at cathode decreases. So CO2 plus يعني decreases. Here at cathode CO2 plus or CO becomes يعني thicker. Strip تتخن أكتر. In general, the color of the solution at anode becomes darker. فإذا على الأنود بنلاحظ السوليوشن becomes darker, while the color of the solution at cathode becomes lighter. بما إنه الكونسنتريشن هون قلت فالcolor becomes lighter، بينما الكونسنتريشن فوق زادت فإذا becomes darker. طبعا إذا كان عنده لون بالأساس، يعني الإكزامبل الماضي Zn2 plus ما عنده color، بالتالي حتى لو صار oxidation بدل اللون the same لأنه بالأساس هو colorless. The reaction can't occur in the absence of a salt bridge. The reaction is spontaneous تلقائية. الجالفانيك سيل فإذا it's a spontaneous reaction. فإذا reaction أبدا ما بتصير إذا ما في عندي salt bridge لأنه incomplete circuit. Metallic wires such as copper wires can't be used as a salt bridge. ليه؟ لأنه ما في عندي electrolyte. فإذا we can't put here for example copper wire، وإنما you must put a salt bridge containing electrolytes. What about the role of the salt bridge? شو دور السولت بريدج بشكل عام؟ First, to complete the circuit. Without a salt bridge, incomplete circuit. It doesn't allow the two solutions to mix, but allows ions to move through it in opposite directions. طبعا الكاتايون بروحوا على الكاثود and anion to anode. فإذا الانايونز اللي بيكونوا موجودين بالسولت بريدج بيتوجهوا على الانود of the galvanic cell and the cations to the cathode of the cell. Also to keep electrical neutrality in both half cells. بيحافظ على electrical neutrality in both يعني beakers. A spontaneous reaction takes place between the strongest oxidizing agent and the strongest reducing agent. فالدلتا E بتكون greater than or equal to 0.3 volt.
A useful galvanic cell can be constructed by using zinc and copper. The anode is a zinc bar placed into a zinc sulfate solution. And the cathode is a copper bar placed into a copper 2 sulfate solution. The two solutions are connected by a porous sodium chloride salt bridge that prevents the two solutions from mixing but allows ions to migrate. Attaching the cell shows that electrons flow from zinc to copper. Because zinc is a more active metal than copper, it is more likely to lose electrons. For this reason, the zinc bar is oxidized, producing a zinc ion and 2 electrons per zinc atom. The copper ions in solution gain 2 electrons and are reduced to copper metal. As the reaction continues, excess positive zinc ions build up in the zinc solution. At the same time, the loss of copper ions from the copper sulfate solution creates an excess of negative sulfate ions. Positive sodium ions migrate into the copper sulfate solution from the salt bridge, while negative chloride ions migrate from the salt bridge to the zinc solution and maintain neutrality of the solutions. The reaction stops when the zinc bar or copper ions are depleted. The overall cell reaction can be written like this.